Hello and welcome to Chapter 9, Section 6, Solving Right Triangles. The essential question is, when you know the lengths of the sides of a right triangle, how can you find the measure of the two acute angles? So if we recall, there's a right triangle. Right triangle has one 90-degree angle, and the other two are small or acute angles. What we're going to learn is how to use inverse of trigonometric ratios and how to solve right triangles. So the first thing we're going to do is we're going to be able to identify angles from given trigonometric ratios. Determine which of the two angles has a cosine of 0.5. So what this is asking, I want to know which angle, either angle A or angle B, that gives me a cosine of 0.5. So I'm going to go ahead and write that over here. I want cosine of a certain angle to be equal to 0.5. Okay, so which angle will give us a 0.5 using cosine, A or B? Okay, so we're going to go ahead and try A first. But before we do that, let's go ahead and talk about cosine. Cosine, if we think of the trigonometric ratio, cosine is the adjacent leg of a right triangle over the hypotenuse of the right triangle. All right, so let's go ahead and start with angle A. What if we have cosine and then the question mark then becomes A, cosine of A, and we need that to be equal to 0.5 or 1 over 2, but we got to follow the rule of cosine. So we're going to do adjacent, which in this case is square root of 3, over the hypotenuse, which is 2. So I have square root of 3 over 2. Now, is that 0.5? It's not going to be, but let's go ahead and verify that. Square root of 3 over 2, and that's 0.8666. 66025, yeah, and so on. So that's not 0.5. So we know that our answer is going to be B. Let's go ahead and verify that using the cosine rule. So if we do the cosine of B, that's going to be the adjacent side, which is 1, over the hypotenuse, which is 2. And we have 1 over 2, which we do have to be 0.5. So angle B is the angle that has a cosine of 0.5. And you can do this for any of the trigonometric ratios. If it would have asked, give me the angle that is the sine of that angle is 0.5, then you would do opposite over hypotenuse, or you can do it for tangent and then do opposite over adjacent and then see which one gives you that value that they're looking for. Okay, so inverse trigonometric ratios are basically the opposite of the trigonometric ratios. So tangent, you just like when you have like 2x equals 4, you do the inverse, divide by 2 to solve for x. The inverse of trigonometric ratios are inverse of trigonometric ratios, which are indicated using a -1 exponent. So let's say those two would be the inverses, not equal to, inverses of each other. Now we're going to do that, use those to find angle measures A, B, and C. So let's say that angle A, B, and C are all acute angles on some right triangle. We're going to be using these inverse trigonometric ratios to find and calculate the measures of these given angles. So let's start with the first one. The first one says tangent of A is equal to 0.75. Okay, so what we're looking for here is this letter A, the angle. How much is that angle? How many degrees is angle A so that it gives us 0.75? So what I'm going to do is I'm going to use the inverse operation to leave the A by itself, to leave the angle A by itself. So what I'm going to do is I'm going to place this tangent inverse next to that, and then this as well is going to take a tangent to the power of -1. Right? That's going to eliminate, leaving us with our A, but this is not just A, it's an angle, and we're looking for the measure. So the measure of angle A, and I'm just putting these on so that we know that it's an angle, and that's going to be equal to the tangent inverse of 0.75. All right, so now how do I actually find this? This is literally all you have to do, and then what we're going to do is we're going to plug this into the calculator. The measure of angle A is equal to, and then we're going to go into the calculator, and we're going to go to this other tab that says function, so the func tab, and then here you see that we have sine, cosine, tangent, sine inverse, cosine inverse, tan inverse. So that what we're looking for is tan inverse. We're going to go back to the numbers and put 0.75, and then that's going to give us our answer there. So this is the value exactly of the angle A. So this is the degree, but it says on the question that we want to round it to the nearest tenth. Nearest tenth is this first decimal place. Because we have a 6 to the right, we're going to have to round that 8 up to a 9. So here we should have 36.9 degrees as the value of A. All right, let's go ahead and try the next one. So what I'm looking for now is angle B, and I know that the sine of B is equal to 0.87. Okay, so easiest way to do this, because I have sine of an angle that I don't know, I'm going to be doing the sine inverse, the inverse of that to both sides, sine inverse. So then I know that the measure of angle B is going to be equal to the sine inverse of 0.87. Okay, we put that into the calculator. Let's do function sine inverse 0.87. Okay, and that's going to give us an angle of 60.4586395 degrees, but we want to round to the nearest tenth, or the first decimal place. So we're going to put 60.5. Boom, and that's the measure of angle B. That's how many degrees angle B is. And then the last one we're doing is the cosine of angle C is equal to 0.15. So for this one, we want to do the cosine inverse. So cos to the power of -1, that's read as cosine inverse. And we're going to do that to both sides. So the measure of angle C is going to be equal to cosine inverse of 0.15 . All right, and we're going to put that into our calculator right over here. Cosine, wrong cosine. Make sure that it has the exponent, because that indicates that it's the inverse. Cosine of 0.15, and then once again, before I move on, make sure that this is on degrees. You see the word DEG, the letters DEG, that's the one we wanted because we're looking for degrees. So we want to have 81.4. Okay, and that's how you use the inverse trigonometric ratios to find the value of a missing angle. So now we move on to the core concept of this lesson, which is solving a right triangle. What it means to solve a right triangle is that we need to find all of the unknown side lengths and angle measures that are not given. So what that means is a triangle has 6 total parts. It has 3 sides, 1, 2, 3, and it has 3 angles, 1, 2, 3. So we need to have all 6 parts identified. So we already have this side and this side, 3 and 2, and we have a 90-degree angle. We know that that's 90, so we don't need to solve for that. But we're going to need to find the remaining side. So this side BA, which is labeled as C, is not a number. We need to find the number value. And we also need to find the measures of our angles here. And we can use what we just did on the previous example, using inverses to find those angles. Okay, but we're going to go ahead and first find the value of this bottom side, the hypotenuse. Okay, and if we recall, and from section 1 of chapter 9, the Pythagorean theorem, I can do a squared plus b squared and equal that to our c squared, which is c squared. All right, and then we can continue here by solving it. 4 plus 9 is equal to c squared. That gives us 4 plus 9 is 13. Right? And then the last step is to take the square root. So if we take the square root, that'll eliminate our exponent. Do that to both sides. So then c is equal to the square root of 13, which if I plug into the calculator, square root of 13 is 3.6 because we want it rounded again to the nearest tenth. So we want to put 3.6, and that is the measure of our hypotenuse. Okay, so there we have it right there. And now we got to find the other 2 missing pieces. So we already know one piece, right? We found the missing side. So this one is done. Check. All right. But what we are missing is 2 angles, angle B and angle A. I'm going to go ahead and find angle A first. B. So to find the measure of angle B, I can use the sides of the triangle and using inverses, just like we did on the previous slide. So if I look here, what are the 2 things that I have that are given to me as sides on the triangle? So I know that this side here is 3 and this side here is 2. Now what I want to do is I want to make sure that I use those 2 values, the ones that are given to me, just because C is approximately 3.6, right? It's 3.6055125 and so on, but we don't want to use that value if it's rounded, because then we're going to get a wrong answer. So I'm going to go ahead and use 2 and 3. So that is the adjacent side of angle B and the opposite side. So if we think of what trigonometric ratio has opposite and adjacent in the same form, okay, then we can use that to figure this out. So opposite and adjacent are tangent features. So the tangent of B is equal to opposite over adjacent. So 2 over 3 is equal to the tangent of B. So now we can do this by doing the inverse. We can find out what B is by taking the inverse. Okay, tangent inverse cancels that out. So the measure of our angle B is equal to the tangent inverse of 2 over 3. So we're going to go to our calculator here. We're going to go to the function, tangent inverse of, and you can just type in the fraction just into the parentheses. You don't have to do it separately. And we're going to get 33.69006753. but we want to round that to the nearest tenth, so we're going to do 33.7. Okay, so 33.7. Okay, and we can also do the same kind of process to find our other missing angle, angle A, and it's going to be the same because I have the opposite and I have the adjacent side, so it's going to be tangent of A is going to be equal to, but in this case it's going to be 3/2. So the measure of angle A is equal to, if we do tangent inverse to both sides, the measure of angle A is equal to the tangent inverse of 3/2. Again, make sure that you press the correct tangent. This is tangent inverse, not regular tangent. Tangent of 3/2. See how that's different? So then we have 56.3. And there we have it. These are the missing values. We have solved the right triangle because we have found the values of all missing parts of a right triangle. Here's another example, but let's take a look at this one. We have a triangle that has two missing sides. On the other one, we had A and B, and we were able to find C. If we were to set this up as A squared plus B squared is equal to C squared, we're going to get two variables, and there's no way for us to be able to solve for that because we have two variables. There's no way for us to do that. So what we're going to do is we're going to use the angles that are given to us to actually find those missing values. So I'm going to go ahead and start with finding angle G. Okay, because I know that this is 25 and I know that this is 90. So if I do that in the calculator, if I say, well, I know a triangle is 180 degrees. If I take away that 90-degree angle and I take away that 25-degree angle, then I know that my missing angle is 65 degrees. So that's how we find a missing angle when we have two of them. If we have two of them, then we can do this 180 rule, thus angle sum theorem, triangle angle sum theorem to find the missing angle. All right, now that we have that at 65, okay, I'm going to use our values that are given to find out the value of our H and G. So I'm going to go ahead and find the value of H first. So I'm going to take a look. I don't want to use this side right here because it has a variable. I want something that has numbers in it. Okay, so let's say I'm going to use this side here that gives me two sides that I can use to set up a trigonometric ratio. Now all I have to do is pick an angle. I'm going to go ahead and pick 25. It could have been this new one that we found, but I'm just going to keep that one there because it was given to us. So I'm just going to use that, and it doesn't matter. So let's say I want to do this angle 25. So what trigonometric ratio can I use if I'm using the opposite side and the hypotenuse? Opposite and hypotenuse. Well, that reminds me of one of my trigonometric ratios. So that would be sine, because I know that sine is opposite over hypotenuse. So then what I'm going to do here to find h is I'm going to say, well, the sine of 25 degrees is equal to opposite h over hypotenuse 13. Now all we have to do is solve for h. If I multiply both sides by 13, I'm going to get h is equal to 13 times the sine of 25. And I can use my calculator to find that value. So then we're going to do 13 times, remember this one is now regular sine of 25 degrees. So then that's going to give us the value of h. H is equal to, or approximately equal to, 5.5 because we're rounding to the nearest tenth or the first decimal place. Okay, that would be our h. Now for g, g is our other variable. Okay, I want to use this. I want to avoid using our h. And again, we can use either of the angles. I can use 25, or I can use this one here that I found at 65. I'm going to do both of them just so you guys can see that you can do it either way and get the same answer. So I'm going to set this up here. If I want to use 25, just like we did on the other one, and I need to use this, okay, so those two parts. From this angle 25, I have G, which is adjacent, and I have the hypotenuse, and I know that adjacent over hypotenuse is cosine. So I'm going to do the cosine of 25, cosine of the angle, is equal to adjacent over hypotenuse. But I can also do this, h, 13, no, not h, cross out h. I could also use this angle that was given to me, that we found, of 65. So then, if I want to use angle 65, my opposite, I have the opposite and the hypotenuse, which is sine. So I can do sine of 65 is equal to g over 13. Now for both of these, I would solve for g the same way, multiply by 13 to both sides. So my g is going to be equal to 13 times cosine of 25 degrees, or g is equal to 13 times the sine of 65. Now I'm going to go ahead and type both of those values into the calculator, and you guys are going to see that we're going to get the same exact number. So 13 times cosine of 25 is 11.78200,123, and then 13 times the sine of 65 degrees is also 11.78200,123. So then I know that that is the value of G, 11.8. All right, that is the end of Chapter 9, Section 6, Solving Right Triangles. You should now be able to identify angles using the trigonometric ratios. You should know what inverse trigonometric ratios are and how to use those to find missing angles of a triangle. And you should know how to completely solve right triangles and anything else that you may or may not have learned. If you have any questions, comments, or concerns about the lesson, please feel free to comment down in the comment section down below. I hope you learned a thing or two, and I will see you guys next time.